look at is the seal plate that has two different seal applications in it. The radial seal, which is a piston and bore type of seal, and the face seal. And again, we looked at those actuating pins. They are pushing this seal plate down into the paddle, like you see there in the left-hand illustration. And when that's being done, the valve is closed. When the valve is operating, the valve is open, which makes it a little bit different and more challenging than a typical seal application. The seal has to resist chemical exposure while the seal is open, right? Or while the valve is open. So the seal is directly exposed. Both of these seals, as a matter of fact, are basically directly exposed to plasma environments or radical gas environments when this valve is in operation. Starting with the face seal, typical challenges of these face seal applications. You're getting extremely aggressive plasma and chemical attack, right? You're getting dynamic actuation where this thing is opening and closing. It could lead to twisting, it could lead to abrasion, it could lead to cracking. Thirdly, if this seal sticks, it could lead to a variety of problems. It could lead to a delay in this valve opening. It can even lead to a part popping out of the groove, right, in extreme situations. With the radial seal, again, it's like a piston bore type of application. The dynamic motion can cause twisting and abrasion of the seal in the groove. And there's also chemical attack at that location as well. So the chemical attack is breaking down the material. And so that chemical stress leads to the seal material failing, typically cracking. So what does that look like? This is what it looks like. We looked a little bit earlier at an animation of the gases flowing. This is what it looks like when the gases come down. Bang, here you go. Gases are starting to come down through the pendulum valve. You can see they hit the paddle and they go between the paddle and the seal plate. That's exactly where these O-rings are, right? So you're basically exposing these O-rings or these seals in this application to direct plasma environments. Very challenging. Plasma and these radical gases attack everything because that was just the beginning of the gas flow. It gets more intense, right? So basically, you're flooding this entire pendulum valve with these very aggressive, corrosive gas environments. Sometimes the pendulum valves are heated, cooled. There's all types of things that you can do with the pendulum valves as well. Sometimes you might see temperatures a couple hundred degrees in these applications as well. So not only do you need to resist chemical attack, you may have a temperature situation that you need to handle as well.